So now the ambiguous case. The ambiguous case occurs whenever you have side-side angle, and it relies on your relationship between side A, side B, and the height of your triangle. And the height of your triangle is always going to equal side B times the sine of angle A. So if the measure of angle A is acute, so we have an acute triangle, and A specifically is less than 90 degrees, then we're going to have this height within our triangle that we are going to compare to. So when you find H, side A, side B, when you find H, it is greater than A, then you are not a triangle. If A equals H, then you are one triangle. If A is greater than B and you're acute, then you are one triangle. But if H is less than A is less than B, then you are two triangles. In the event that A is obtuse, then your height falls outside of your triangle from B. And if your angle is obtuse and your A is less than or equal to B, then you're not a triangle. Or if your A is greater than B, then you are one triangle. Okay, so if you are less than or equal to B and your angle A is obtuse, then you can't be a triangle. If your A is greater than your B, then you're one triangle. So what does that look like exactly? Well, normally when they ask you this question, they're just simply asking you how many triangles can be formed. So if we look at a few examples, you are going to determine how many triangles. So when I look at how many triangles, this will be example number 3 for us because we've already done 2 examples. If I tell you that A is 15 and B is 25 and the measure of angle A is 85, then you ask yourself 2 questions. One, am I acute or obtuse with my angle A? So we're acute. So we're going to be looking at 3 different scenarios, either not a triangle, one triangle, or 2 triangles. And so I need to find my value of H. So to find H, I'm going to take my B value and multiply it by the sine of my angle. And when I do that, this is going to give me 14.9. And so now what I do is I compare it to my value of A. So I have 14.9 is less than 15 is less than 25. So this means H is less than A is less than B. And anytime that happens, we could be 2 different triangles. And the reason that happens is here's the triangle that I currently have. A, B, C. B is 25, A is 15, and the measure of angle A is 85 degrees. Well, if I draw in my height here, well, since the only contingent factor is that I know that this angle this side length has to remain constant, I could technically have this acute angle 85, or if I move this in, then I could have another triangle that would be obtuse. And so what would vary is going to be the length of your side B, but your angle on this side is going to remain constant. So you could have two different triangles. You have this acute triangle with an angle of 85 degrees, or you could potentially have the obtuse triangle that has an angle of 95 degrees inside it. To look at another one for number 4, if I tell you that A is 22 and B is 12, and the measure of angle A is 42, well, then I need to know what is my H value. So I have 12 times the sine of 42, and this is going to give me 14.7. So at this point, I have 14.7 is less than 22, but 22 is greater than 12. So I have A is greater than B, and my angle is acute. So since it's acute and my A is greater than B, then that means I have exactly one triangle. There's only one way to draw this triangle, and it still fulfill all of these requirements. And the last thing we deal with our law of sines is how to find the area of an oblique triangle if we're not given all of the information. And so to find the area of your oblique triangle, your area is equal to half of side B times C times the sine of angle A, or you could have 1/2 A times C times the sine of angle B, or you could have 1/2 A times B times the sine of C, depending on the pieces of information that are given to you. So in the next video, we'll work through some example problems and get you started on some exercises.